Hello, and thank you for joining us on the latest episode of Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley. I am your host, and it is great to have your company once again. Coming up on this episode, it's a jam-packed episode. A coronal mass ejection has destroyed a bunch of Starlink satellites, and that's been a bit of bad news. We'll talk about that and why it happened. And a rocket body is about to hit the moon. And it's not got anything to do with Starlink, so completely different scenario there. But on the good news front, the James Webb Space Telescope has snapped its first image, and it wasn't a selfie, although I think it's done that too. And a third Earth-like planet has been found orbiting Proxima Centauri. We will also tackle some audience questions about hitching a ride on a passing object to help us get where we want to go to save fuel. I like the idea. Ralph's having trouble with his telescope. You should never have pulled it apart, Ralph. I'm telling you right now. And Peter wondered what we would go back in time to witness, some kind of astronomical event. If we could make a choice of one, what would it be? So that's a great what-if type of question. Love what-if questions. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me, as always, is the great man himself, Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. How are you?
I am quite well, feeling very refreshed after a little trip. Judy and I did a little journey down to Melbourne. We saw a bit of cricket. We went to Brighton Beach, walked to St Kilda, saw the ladies' cricket, the international between Australia and England. Then we went to Hobart and did a bit of sightseeing there. Went to a gallery, which you can get to by ferry. And this was a really strange ferry, Fred. The seats were sheep.
Oh,
The seats were sheep. I did feel a bit sheepish taking such a seat.
of course.
There was an expensive section of the boat for other people. We didn't have the money for that, but I wouldn't sit on the sheep because I felt sheepish about doing that. And I found out why they put the sheep on the ferry. It was so that they could achieve ramming speed.
Oh, gosh.
Sorry, I'm trying to pull the wool over your eyes, Fred. And I also found out they are merino sheep.
Okay, there you go. Yeah,
Merino
I do.
sheep.
Merino, yeah.
Yeah, you bet.
Any more?
You bet there are.
Oh, I bet there are too, yeah.
You've got to think about it. How are you, Fred, by the way?
Fine, thanks.
Yeah.
I'm on a night schedule at the moment because I'm attending
You were at a virtual conference last night.
I was, and we'll be at it again tonight. This is a meeting of the United Nations Committee on the Peaceful Uses of Outer Space, which I've been attending as one of Australia's delegates.
Wow.
And in fact, did a
That's
presentation.
big stuff.
It is. It's grown-up stuff, is that? I did a presentation last night on our efforts in keeping our skies dark and quiet.
Yeah, which is very difficult to do.
It is.
The moment.
It is at the moment, yeah. But it's all right. We're working on it.
Yes, indeed. Speaking of which, we have heard in the recent news of a coronal mass ejection that has destroyed a bunch of Starlink satellites. What exactly happened?
Yeah, this was at the beginning of February. I think Thursday, the 3rd of February at 1:13 p.m. Eastern Standard Time in the US. Falcon 9 launched 49 satellites to low Earth orbit. But unfortunately, there was a geomagnetic storm the following day. And you'll remember, Andrew, that the Starlink satellites, when they're launched, they're in this string of satellites as they ascend to their orbital height and disperse to their orbital shells. So they were still in that process, in other words, at a fairly low altitude, around about 200 kilometers, when this geomagnetic storm hit. Now, it's not the geomagnetic storm itself that kills the spacecraft. It's the fact that it fluffs, that the storm fluffs up the atmosphere. It causes the atmosphere to warm and atmospheric density to increase. And in fact, the sensors on the spacecraft and the telemetry from those spacecraft showed that the atmospheric drag increased by up to 50% more than it had been before. And that was a serious problem. So what the Starlink team did was put the spacecraft into a safe mode. So they're flying sort of edge on to minimize drag. But the net result is this is that up to 40 of the satellites didn't make it. They either will re-enter or have already re-entered the Earth's atmosphere. And of course, with zero risk, these things, well, they weigh a quarter of a ton. They're not small, but they're certainly small enough to burn up completely in the atmosphere. So it's, actually, and might quote from SpaceX's website on this. It says, "This unique situation demonstrates the great lengths the Starlink team has gone to ensure the system is on the leading edge of on-orbit debris mitigation." In other words, they haven't left any bits behind. They will all have re-entered. So unexpected, perhaps. It's something that I wouldn't have foreseen. But when you're launching so many satellites, then this kind of thing is bound to take place from time to time.
Yeah, it was going to happen at some stage, or something was going to happen. To lose 40 in one go, though, that's pretty expensive.
It's expensive stuff. I mean, fortunately, the company has deep pockets, but and you've only to look at what's happening with their Starliner project. By the way, just throwing in an aside, SpaceX is hoping to have the first orbital launch of its Starliner, I think within a month. So you and I might be talking about that down the track. That's going to be really spectacular.
Incredible. Well, we're still into things not going quite right, although this is not quite the same. A rocket body is about to hit the moon. Is that right?
Yes, that's right. Now, I can't remember whether we spoke about this last time.
We did mention it because there was a project asking backyard astronomers to take photos of the moon around the time that this was supposed to happen, so that they might be able to find it.
Yeah, it was. That's right. It was to get image. It was actually to get images when the object flew closest to the Earth to give a better calculation of its orbit, so you'd be able to work out from that where it was going to wind up on the far side of the moon. And I think that work has continued. But there's been a rethink because everybody was cheerfully blaming Elon Musk because it was thought that this was a Falcon 9 body from a launch of, I think, of a solar research spacecraft. In fact, it was the Discover spacecraft launch vehicle. Discover's it's an interesting spacecraft that sits at the L2 point and looks back at the Earth. That's the L2 point is between the Earth and the Sun, as you know. No, it's not. That's the L1 point. Sorry, L2's on the other side. Ta-da!
That's right.
Anyway, notwithstanding that, it's a rocket body, and that launch was some years ago. But further calculations have been done, and it's now thought not to be a SpaceX Falcon 9 rocket body, but one of the remnants of the launch of China's Chang'e 5, which was launched on October the 23rd, 2014. And it was actually a test run for future launches. Chang'e is the Chinese lunar exploration project, and we've got the U-2 rover on the moon, on the far side of the moon at the moment. So it's now thought to be the Chang'e 5. In fact, it's called Chang'e 5 T1 body that, or the launch vehicle itself that launched that spacecraft. Just a footnote there that the fact that it's going to this rocket is going to hit the far side of the moon. It would be very unfortunate if it hit if it hit the site of the U2 rover on the far side of the moon. But it's thought that it will actually be U2 is right down near the southern pole of the moon on the far side. This impact is expected to take place more or less in the middle of the moon's disk.
Yeah, it would be terrible luck, but the odds,
wouldn't it? Yeah, it's a bit
the
like
odds of hitting target would be pretty remote. But
I mean, it would be the same sort of thing as the lens cap falling off the Venus probe onto the bit that you're trying to photograph. Which happened to one of the Soviet Venerat probes back in the 80s.
Yep, it melted, didn't it?
Yes, I think most of it melted. That's right.
Yeah. That was just plain bad luck, but you could never predict it. It was just, I think, an oversight of the conditions. But what can you do? All right. So that's due to happen when?
Well, the last date I remember is March the 4th. It may have changed, but that's we'll know perhaps more accurately nearer the time. But I think March the 4th.
So if you're a backyard astronomer, get out there and do some happy snapping and see if you can get some pictures of it as it gets in there.
Well, you won't because it's on the far side of the moon. By that time, Andrew, it's beyond the reach of amateur telescopes.
Right. I think they wanted the photos sometime around.
Yeah, that's right. There's that's exactly right. That's it.
Yeah, that's right. I remember now.
Yeah, remember.
Now, while we're talking telescopes, which we weren't, but we are now.
Yes.
The James Webb Space Telescope has snapped its first image. What did it take a photo of?
Oh, well, a star, a nice bright star, which is one that was chosen. It rejoices in the name of HD 84406. It's in the Northern Hemisphere constellation of Ursa Major, the Great Bear. And so it's a bright star. But what led the NASA mission team to choose this star is it's fairly isolated in that part of the sky. It's you're a long way from the Milky Way, and so it's an isolated bright star. And what they wanted to do was, why did they want it isolated? Because they're going to take multiple images of this. Each of the 18 mirror segments makes its own image because they're not yet aligned. So what you get is 18 images of this star on the detector. And the last thing you'd want would be half a dozen other stars in the same field of view that are confusing what it is you're looking at.
Oh, now I understand what I'm looking at.
Yeah. So that picture, Webb's first star image, which I think has been widely circulated, has 18 little white dots on it. And each of those is one separate image of HD, whatever it was, that star, HD 84406. And so the work that will now begin is in aligning the mirror segments so that you end up with them simply forming one image. And that will be, something to look forward to, because then we'll start seeing real pictures from the Webb.
Oh, yeah. So they're going through the protocols to get the whole thing lined up and ready to do what it was designed to do, which is the most exciting part, but still some work to be done. HD 84406. I used to work for a radio station called HD.
Oh, did you?
Yeah, in Newcastle, 2HD. It was out of this world.
Do you know? Oh, yes, it would have been. What did the HD stand for? Do you know?
It did. I think it's were the initials of its founder, if I remember rightly.
What I thought they might be. Well, maybe it could be the same, because this HD, it means that this star is in the Henry Draper catalogue of stars. That's what the HD stands for.
Yes.
Yeah.
Yes, we've spoken about Henry Draper a few times.
Indeed.
All right. So, yes, all systems go still at this stage for the James Webb Space Telescope, and we wait with bated breath for it to get down to business and answer all the questions that you ask us all the time that we can't answer for you.
Yeah, until the Webb tells us what the answers are.
That's right.
Yes.
Exactly.
Indeed.
This is Space Nuts. You're with Andrew Dunkley and, of course, Fred Watson. Now, I've talked before about our sponsor NordVPN, and if you don't know what a VPN is, then I'll give you a brief overview, but it's a virtual private network. It's like putting up a brick wall between your computer and the outside world, and it's basically designed to secure your internet access, secure you from hackers, from anybody who'd want your private information, whether that's bank details, email addresses, contact information, anything they can use to take advantage of you as an individual for their financial gain. It also protects you in public situations like airports. If you use airport Wi-Fi, for example, it's not secure. It's just not secure. But you can open your laptop or your tablet or your phone, turn on your NordVPN, and voila, the brick wall is there to keep you safe and secure while you browse at your leisure. And it doesn't slow you down. In fact, in some cases, NordVPN makes things a lot faster. The other thing that's really good about it is you can access their servers through 59 different countries, and that enables you to access geo-blocked sites or content that you can't get through just using your local server. So that's something to think about. Now, there is a special offer, as always, with this as a Space Nuts listener. So the URL you need is nordvpn.com/spacenuts, and you use the code SpaceNuts to get a huge discount off your NordVPN plan. Plus an additional month for free, and it's completely risk-free. Nord has a 30-day money-back guarantee. So grab your exclusive NordVPN deal by going to nordvpn.com/spacenuts, using the SpaceNuts code to get that discount on your NordVPN plan, plus an additional month for free and a bonus gift. It's completely risk-free. That gift, it's different under every circumstance. So, you might get a really nice surprise. So check it out today, nordvpn.com/spacenuts, the code SpaceNuts to get that discount and all those additional benefits as a Space Nuts listener. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, as I've mentioned many times, we are on social media. So if you'd like to become a follower of Space Nuts on Facebook, we've got an official Space Nuts page there. We've got an official Instagram page. We're on Twitter. We also have a Space Nuts podcast group where everybody can talk to each other about Space Nuts and other things that are happening in astronomy. People often ask each other questions, or they throw a question out there and everybody has a crack at answering it. It's really good fun. It's a great group of people, and you're more than welcome to join it. And that's the Space Nuts podcast group. At whatever form of social media that you use, if you do use it, you will find Space Nuts there, and we encourage you to join us. Now, Fred, I was going to get straight into this next subject, but I thought I'd bring up a little bit of a personal thing, because we, in our recent trip, were in Melbourne, and we went to a place called Science Works, which is a facility aimed primarily at kids, but I'm a kid at heart, so I wanted to go and have a look at this place, and it looks at all sorts of science issues, from food right through to artificial intelligence, to you name it, it's covered in science and astronomy. And they've got the Melbourne Planetarium there, which is a fantastic facility, because one of the things that we looked at while we were watching the show in the planetarium was Proxima Centauri. And we're going to talk about that in a minute. But the other thing I stumbled across quite accidentally, because I'm a bit of a sticky beak, and I went down into the bowels of this facility and I found a telescope and realised that they were restoring the Melbourne telescope. And I sent you a photo of it, and you wrote back and said, "Oh, yes, I know all that. I'm the patron of that." So tell us a bit about what's going on.
Well, yeah. Oh, look, this is a marvellous story, Andrew. This we don't have time to give it justice here, but this telescope was built in 1869 by the British firm of Howard Grubb, and that's the company that I began my career with.
Oh, wow.
Just about 100 years later, I think. Yes, in fact, just about 100 years later. So I've got a very close connection with the company that built it. It came to Australia, was part of Melbourne Observatory. It was the biggest fully steerable telescope in the world for a long time. It has a 48-inch diameter mirror, which was made of metal. it didn't live up to all its expectations. And in the early 20th century, fell out of use. And eventually, in 1944, I think, the Melbourne Observatory was closed as a research institution. And Mount Stromlo Observatory in Canberra bought the telescope for scrap. But they didn't scrap it. They refurbished it using some of the components and gave it a completely new lease of life. It worked for it was best part of, no, more like 45 years, something like that. Was refurbished twice. One of the things it did was demonstrate that dark matter can't be lots of black holes and things of that sort. It's got to be some subatomic particle. Did lots of things. Then, 2003, I think can't remember the date. It was certainly January. The observatory burned down in the bushfire of January 2003. The telescope, effectively, a lot of it melted, believe it or not. It was the dome melted aluminium onto the telescope structure. The more modern part of it was damaged much more. I wrote about it in my book, Stargazer, The Life and Times of the Telescope, which was published not long after that, and said, this is never going to be recovered. It might end up in a museum. And then in 2008, this gang of people got together and said, we can refurbish this.
We can fix it.
And that's what's happening. It's a combination. Let me get it right. It's a while since I've thought about this. It's Museums Victoria, the Astronomical Society of Victoria, the Royal Botanic Gardens in Melbourne, and I think the Bureau of Meteorology is involved as well. So fabulous project. The reason I'm its patron, I guess, is partly because, well, let me tell you, when I was a youngster, I was still at school, I had a book from the library by Henry King called The History of the Telescope, and it had a picture of this marvellous looking, fantastic machine in Melbourne. And I said to myself, I want to use that. It's my favourite telescope, and it has been ever since. So,
I might get Hugh to put the photo I took of the Melbourne telescope on our cover page for the podcast.
Yeah,
because it's a beautiful telescope.
It is.
It's just lovely.
It's stunning. It was pristine mid-19th century engineering. Unfortunately, some of the technology was out of date. Mechanically, it wasn't, but the optics were, and that is what conspired to its demise. But it's got this new lease of life. The idea is it'll be in a science centre in Melbourne, and people will actually be able to look through it.
Yeah, I nearly didn't see it. I was just walking along. We were about to come up a set of stairs, and I saw a sign, and I walked past it, and it must have taken 10 or 15 seconds for my brain to go back, Andrew, go back. I subliminally read the sign, and I went back, and I said to Judy, hang on a sec.
Yep.
And I rushed back down the stairs and went through into this workshop.
Yes, that's right. They've got a viewing gallery in the workshop. I was there actually in 2019 when this all happened. I did a little keynote presentation on it, which I was very excited to do.
It's worth going along just to see that. If you're in Melbourne, the Science Works facilities at Spotswood, it's an easy train journey from central Melbourne, and just a great facility. And if you've got kids, they will love it. They will absolutely love it. It's a terrific place. Lovely people too, even though they paid me out for not talking enough, which was very, very rare indeed.
Great stuff.
To the subject of this segment, and obviously telescopes have a lot to do with this, and so do planetariums, because that's how we got onto this subject in the first place, because I was looking at Proxima Centauri and the Melbourne Planetarium. But the news that's out now is that a third Earth-like planet has been found orbiting Proxima Centauri, which is very exciting because it's the closest to us.
That's right. It's the closest star to our solar system. And this it is an exciting discovery. There's a nice quote, actually, from one of the astronomers who discovered the first planet back in 2016, orbiting Proxima Centauri, a scientist by the name of Guillem Anglada Escudé, who is at the Institute of Space Sciences in Barcelona. And he said, this is showing that the nearest star probably has a very rich planetary system, because if you find three planets orbiting this dwarf star, which is what it is, there's a good chance there are more smaller objects. And in fact, the newly discovered planet, and it's actually astronomers, I think, from Portugal. Is that right? Yes, University of Porto in Portugal. They used the Very Large Telescope, which is kind of at the other end of the scale from the Great Melbourne Telescope that you went to see. This is 4 8.2-meter telescopes at Cerro Coronal in Chile. And one of them has an instrument, I love its name, it's called Espresso. And it makes you think of coffee. And it's an acronym for, wait for it, Andrew, a shell spectrograph for rocky exoplanets and stable spectroscopic observations. There you are.
I love it.
Yeah, Espresso is a fantastic instrument for discovering planets by the Doppler wobble technique, in which you look for the motion of the parent star as it's pulled out of place slightly by the motion of the planet. So what have they found? Well, an object by the name of Proxima Centauri D. So B, C, and D are the three planets that we now know. It is actually a sub-Earth. It's not so much an Earth-like planet. I've got a feeling it's something like 25% of the mass of the Earth. Is that right? Yeah, it's a sub-Earth rather than an Earth-sized planet. It orbits its parent star every 5 days. So it's whizzing around. And of course, that's because Proxima is a dwarf star. So its planets are much closer in because its gravity is less than the sun, much closer in than the planets of our solar system. And this one, as I said, it's actually only about 0.03% of the distance that we are from the sun. And it takes it 5 days to go around.
Yeah. I think they've referred to it as a provisional planet. They haven't actually
yes, that's right.
Planet status yet.
It's still got the candidate status. Now, Proxima B, which is I think the first one that was discovered, is actually within Proxima Centauri's habitable zone, the Goldilocks zone. So that could have liquid water on its surface. That goes around the star once in 11 days, so it's further out. The problem with Proxima is it's a red dwarf star. So even though you might have liquid water on one of the worlds, there are these flares that that makes the flares that our sun spits out look pretty tame, and they're very high energy events which could fry anything that's trying to grow on Proxima Centauri B. So the other end of the scale. So that's the two planets that's B and D, which we've just discussed, which are within a few million kilometers of the star. But the other one, Proxima Centauri C, is actually 50% further away from Proxima Centauri than we are from the sun. So it's 220 million kilometers, and goes round every 1900 days. So roughly every every 5 years, every 5.2 years.
So it's at the other extreme.
Yeah,
it's probably a very cold world, is it?
Well, it will be, because Proxima is a dim star, and it's sitting there at the distance Mars is from the sun. So not much heat going out to Proxima Centauri C.
Yeah, well, Mars is pretty darn cold, isn't it?
It is. Yeah, and that's with a sun-like star. So, a very interesting comment from Dr. Angelada Escudé, who about it's probably got this really very rich planetary system. So you can bet your life there's going to be more discoveries, and I bet it's not very long before the James Webb Telescope points in that direction.
Oh yeah, we've got to have a peek at our nearest neighbours for sure.
Indeed.
All right. So that's a bit of exciting news, although it doesn't sound like this latest planet is at all habitable and may not be able to sustain any life given its distance from that red dwarf. But an exciting discovery nonetheless.
Very much so.
This is the Space Nuts podcast, also a radio show heard on the Community Radio Network around Australia with Andrew Dunkley and Professor Fred Watson. Let's take a little break from the show so we can talk about our sponsor, Magic Mind. Now, last week, if you were listening, you might have heard me talking about this. It's a rather incredible product that is designed to, do all sorts of things, but sharpen your mind, your concentration, your focus. And it's all put together through a series of products. And they come in these cute little shot bottles. I'm holding one right now. And it's a product that's aimed to give you better perception, better mind skills, wake you up, take away that reliance on caffeine. That's how this all started. The developer of the product was having some issues with overdosing on coffee, and he ended up in hospital. James Basharan is his name. And he was a Silicon Valley mogul, and, he needed to kickstart his day, so he used to douse himself in coffee. Well, not literally, but, he'd drink a lot of it, and it started causing heart problems. And he thought, there's got to be a better way of doing this. And so he started putting his mind towards a drink, a supplement, if you like, that was purely natural, but did the job to enhance your thinking. So I put myself up, after they approached us, as a bit of a guinea pig to see if this worked. My main objective was to see if it helped me with my golf, because golf is a thinking game. And I thought, if I want to be sharper on the golf course, I need a sharper mind, reduce my mistakes, think better, think more strategically. So I'm still in the process of doing that. But before today's show, I took my first shot of Magic Mind. And I got to tell you, and I said last week I would be deadly honest, I played golf this morning, and Fred and I recorded the show in the afternoon. So I came home feeling pretty weary. My brain was spent, because 4 hours on the golf course is very taxing on the mind if you're concentrating for that long. And I usually come home pretty tired and run down and ready for a sleep, to be honest. About an hour before our recording time, I took a shot of Magic Mind. Now, I didn't know what to expect. And when you read the description, it's got matcha that gives you energy, adaptogens to help relax. This is off the bottle. Nootropics to keep you focused, and honey to make you happy. And I know that works. I love honey. And basically, you just shake the bottle. I took mine chilled, which is what they recommend, and I just took it as a shot, like you do a shot glass, and I waited to see what happened. And I must confess, I was dubious. I didn't think this would do the trick for me. But within an hour of taking the shot, I started feeling much more alert. And that was unexpected, especially after spending 5 hours in the heat in our summer at the moment, and coming home from golf. I was very, very weary. But that was, 3 hours ago I took that shot, and I'm still feeling quite pepped up. And I do believe that it is working. Now, it's only day one of the experiment. I'll be taking a shot of this every day for 2 weeks, and I'll give you a progress report next week. But if you would like to try this for yourself and maybe join me in this experiment, or you think this is what you need in your life, something to pep you up, to take your reliance away from coffee, they do recommend you take it with a coffee in the morning if you're a coffee drinker. But they also suggest that it will replace coffee in your life. And that's got to be a good thing. But give it a try. Now, the way to get hold of this is online. Now, there is a special URL and a special offer for you as a Space Nuts listener. So all you have to do is go to magicmind.com/spacenuts, and it will take you to the page where you can read all about it for yourself, and you can buy your own pack of Magic Mind. And so far, so good. I really feel quite wide awake at the moment, and it's 4:30 in the afternoon, and I've been up since 6:30, and I'm 59 years old, and I don't usually feel this good this late in the day. So I think it's having an impact. magicmind.com/spacenuts. You can read all about the discount offers there and get your own pack of Magic Mind. It might just do for you what I feel like it's doing for me. day one of this experiment. I'll let you know how it goes in the next episode. By then, I'll have downed 8 shots of Magic Mind. That URL again is magicmind.com/space nuts. Let us know how you go. We'd love to hear your feedback as well. Now, back to Space Nuts.
3, 2, 1.
Space nuts.
Now, Fred, we have some questions, and our first one comes from Andrea.
Hello, this is Andrea from Worcester, Massachusetts in the United States. I was listening to your conversation about trying to catch up to Oumuamua with a spacecraft and maybe using space sails or giving your spacecraft somehow a boost to get there quickly. I know it takes such a long time to get from our galaxy to another, and it made me think, could we ever hitch a ride on like Oumuamua or another asteroid or comet or something? I don't know if they travel more quickly than a spacecraft could with the fuel limitations of a spacecraft. Could we somehow have the spacecraft orbit an object and kind of hitch along for a ride, kind of see where it goes, and that could help us get further quicker? Probably an inarticulate way to ask it, but I think you'll get what I'm talking about. Thanks.
Yep. We do get it. Thanks,
it.
Andrea. Lovely to hear from you. And I'm holding a book, if you're watching us on YouTube. It's called 2312 by Kim Stanley Robinson. I've read this book, and the reason, it's a science fiction novel, but the reason I bring this one to your attention, Fred, is that in this book, the human race travels around the solar system in hollowed-out asteroids.
There you go.
So that's what Andrea's asking. Could we somehow harness that energy and use it for long-haul travel? Like, it's certainly worth investigating.
There's a problem with the orbital dynamics here, because if you've got a spacecraft that can achieve enough velocity to catch up with your interstellar visitor, you don't need the interstellar visitor because it will just follow the same trajectory. And so I think it would be possible to do it, but I don't think it offers any advantage. But you'd have to have, we've talked about the plan to catch up with Oumuamua in 2054, which you and I are both looking forward to discussing on Space Nuts at the time. But, that the spacecraft that does that has to be able to achieve effectively the same velocity as Oumuamua. In fact, it's a bit worse than that because it's got to be going faster than Oumuamua to catch it up at all. Otherwise, it'll never get to it. So you're already ahead, if I can put it that way, of the spacecraft. I wonder if you could perhaps achieve something by if you could hitch a ride on one of these things on its way in, where you're heading out to meet this thing. But you've then got the problem of a spacecraft that's going in the wrong direction. The problem is you've still got to accelerate your spacecraft to have the same speed as Oumuamua or whatever it is in order to hitch a ride with it. And since you're doing that, you might as well forget about Oumuamua and just use your spacecraft. It will be a lot more convenient.
We have shown that we can do it with some recent asteroidal intercepts.
Yes, that's right. Yeah.
Some of them went well, some of them didn't.
These were all in the solar system, of course. They were within our solar system. Andrea's talking about hitching a ride to another galaxy or something via Oumuamua or any number of future visitors that we might have. I see your point. We'd have to go to a lot of work and effort to catch it. And by the time we'd achieved that, what would be the point of landing on it using its velocity when we're already doing it? Unless you needed,
unless we wanted to save on fuel, but you'd need to be able to get off at some stage to hit a destination because there's no guarantee it's going to get where you want to go.
That's right.
It could be a problem.
I guess the only thing, the only real motivation for doing that would be if the object had resources that you wanted to exploit, digging up its precious metals or whatever. But they're no good to you if you're being carried out of the solar system at 23 kilometers per second.
And you'd also have to consider what future dangers it might put you in.
Yep.
But it would have to travel a long way to reach that point, I imagine. So,
So the moral of the story is stay away from interstellar objects.
Yes. Okay, let's. Thanks, Andrea. Lovely,
great question. Really great
Very
question.
good question. Yeah. Now, Ralph has sent us a question, Fred, and he's asking you about help with his telescope. Apparently, he's having some issues.
Hey guys, Ralph from California again. I have a couple questions about what Dr. Fred Watson spoke on, which was aperture fever, which I got. I ended up with a light bucket, a Coulter 13.1 inch Dobsonian telescope, the tube. I just got the optics off of eBay. I renovated the thing, put it all back together, and I'm having a heck of a time collimating it. I wonder if Fred had any tips on that. Maybe I need a new primary mirror cell. Not sure. The second question was around binoculars. These are hardware questions. Any tips on the best way to use binoculars? I usually start off doing the general focus with my left eye, right eye closed, and then I use that right eye secondary focus to do the right eye, and then hope for the best. Thanks, guys. Love the podcast as always. Keep it up, nuts.
Thank you, Ralph.
Great question.
Sounds like he's got a couple of issues, though.
Yeah. So what we call collimating telescopes, it means getting all the optics aligned. And with a Dobsonian telescope, whose optical system is what we call a Newtonian. It's a dished mirror, a large dished mirror, and then near its focus there is this flat mirror, which is at 45 degrees to the axis of the dish mirror and sends the light out the side, and that's where you put the eyepiece. And so the trick is to get the main mirror so that its axis is pointing right directly into the flat mirror and your eyepiece. And the way to do that, usually the way is to look at a star image under high magnification, and there'll be rings around the star image if you've got good conditions, which will be distorted if the thing is out of alignment. Now, the problem is you want, Ralph mentioned the mirror cell. That's basically the casing in which the mirror itself sits. And they usually have bolts on the back, screws on the back, or adjusting screws, if you like, so that you screw it in one side and it tilts the mirror very slightly, screw it back and it tilts it the other way. Now, if they are conveniently placed and if they're free to move and not seized up, then it's a relatively straightforward process. But if you've got something old and beaten up, and many of these things are, then it might take some patience and quite a lot of WD-40 to free it up and things of that sort.
Do they have WD-40 in the United States?
I don't know. I guess they might do. They'll certainly have their equivalent.
You know why they call it WD-40?
No, why?
Because it was the 40th variation of the formula, and it's the one they got right.
Right. Okay. Yeah.
So they had 40 attempts at coming up with the formula for WD-40. So if they got it right on WD-39, well, that's probably what it would have been called.
But what does the WD stand for?
I can't remember.
Oh, there you go.
Now I have to look it up. Well, I'll look it up while you answer his question about binoculars.
Yeah, all right. Yes, that's a good idea. And what Ralph said about the adjustment of binoculars is right. That's the way to do it. I have a weakness for binoculars, as you know, Andrew, particularly historic ones. In fact, I have nearly 200 in my collection, which is embarrassing because I haven't got anywhere to put them. And they range in size from tiny miniature ones to the World War II Japanese battleship binoculars, which have got 5-inch lenses at the front. They're colossal things. Anyway, that's notwithstanding. But I love using binoculars because particularly
The neighbours don't appreciate it.
Well,
but
yeah, we've got to be careful. That's right. Partly because at night, of course, they let you use two eyes to look at whatever the objects are that you're looking at. In the landscape, they're lovely because they bring out the depth perception. If you've got stereoscopic vision in your eyes, reasonably proficient. But the technique with what are called center focus binoculars is indeed to close your right eye. In fact, what specialists recommend is that you don't close your right eye, that you cover up the lens on the right-hand side, leave your eye open, because the act of closing the eye changes your adjustment a little bit. So you cover up the lens on the right side, do the adjustment for your left eye, and then you turn what's called the diopter adjustment on the right-hand side to bring the two into focus. Now, the pitfall with that is sometimes binoculars are a bit worn, and when you turn the adjustment on your right eye, I'm doing it, you can see here. If you're on YouTube, when you turn that adjustment, then you disturb the adjustment of the other side, just because there's a bit of wear in it. And for that reason, I actually prefer, although they're not so easy to get these days, I prefer what are called individual focus binoculars, where each eyepiece focuses separately. It's not so good if you're looking at sports or something like that, where you need to change focus quickly and often. They're inconvenient. But for sort of serious looking at the landscape or the sky, the individual focus binoculars are better. But as I said, they're not that easy to get hold of these days.
Yeah. WD stands for water displacement.
There you go. We should have guessed
that. It's the 40th version of the water displacing formula.
40th recipe.
Yeah.
It's pure.
For those who don't know what we're talking about, it's a spray can of stuff that, it does all sorts of things.
It frees up things, stops them rusting. Yeah,
to de-rusting bolts. It does all sorts of amazing stuff. It's good gear, actually. It's really good, very handy stuff. Water displacement 40 is
there
what
you
it was.
go. There you
40. Hopefully, Ralph, your telescopic and binocular questions have been resolved, or issues. Let us know how you go with getting that Dobsonian working.
Yeah, be good.
But I can understand his frustration with using a telescope or binoculars, because I've found with mine, the first few times I used it, I tried looking through the eyepiece with both eyes open, and that doesn't work. Just doesn't work. Not for me anyway. But if you close an eye, that's not advised.
That's right.
So they suggest you cover the eye you're not using, so you can. And I find it very hard to do that. I'm not used to it yet, but I'm guessing I'll get used to it sooner or later.
Do you use yours with an eyepiece prism, which lets you look down into it rather than straining to look up?
I can show you, Fred.
Yeah.
Hang on a second.
Drew's going to show me.
There you are. So it's got the diagonal.
Yeah, that's at 45 degrees. I prefer the 90-degree version.
I haven't got that.
No, it means you're looking directly downwards. And if you've got a dark night, it's a lot easier to keep one eye open because you're looking at the dark background, you're looking at the ground, unless it's moonlit or something. But the other issue, which you can do, you travel business class on Qantas very frequently. I know they have
we've done it once by accident.
they have very good face masks, and if you put one of those on and just tilt it so that it's only covering one eye, you look completely mad, but and your wife will think you've lost it completely. But it does the trick. It means you can keep your eye open and not see anything.
She won't go outside while I've got a telescope. That's just too weird for her.
There you go. Yeah, especially if you've got one eye covered.
Thank you, Ralph. And as I said, let us know how you go. One final question. We're going to throw in a bonus question this week. This one comes from Peter. This is a what if. I love these kinds of questions. Here we go.
Hi, Andrew and Fred. My name's Peter, and I'm from the Sunshine Coast, Queensland. I'm a long-time listener, so I've got a handful of questions I'd like to ask eventually. But I'm a first-time caller, so I thought I'd start with an icebreaker question. And my question is, if you could go back to any point in the Earth's history to witness an astronomical event, what would it be? when was it, and why? I imagine there's things that researchers have found, but only found trace evidence, and they haven't got all the pieces of the puzzle. So going back might reveal some of the mysteries. Or maybe there's an event just so spectacular you have to see it with your own eyes. Anyway, that's my question. I hope it's a bit of a break from some of the black hole and dark matter questions that you get. Love the show, and you will hear from me again with some of my other questions. Thanks. Bye.
Thank you, Peter. I love the questions. I love the idea of putting us in these situations. I really enjoy these kinds of scenarios. Can I go first?
Yeah, sure.
Because yours will be really intelligent.
I bet you and I choose the same one, actually.
Or inspiring. I've actually had a couple of thoughts. As soon as I heard that question, when I first listened through all the questions that have come in this week, my first thought was Tunguska. Mm-hmm. I think I'd love to go back and just see what happened. I want to know what happened.
In 1909, yeah. Back in 1909.
Yes, yeah, I think that would be, because it happened in such a remote area, hardly anybody saw it.
Yeah.
I don't think there were many witnesses at all. They just found the evidence of it later, which was just, hundreds of square miles of flattened forest. I would love to see that. I know they've sort of seen it in Russia in recent times, but Chelyabinsk. But I think Tunguska for me is the event I would like to witness, just so I can understand the magnitude of such power and ferocity. On a lighter note, Roswell. The Roswell incident.
Yeah. Well, you might be waiting a long time for that, because I don't think anything happened. No, that's great. That's really good.
What about you, Fred?
Yeah, look. So some of the the events that you think about would be marvelous to see, like the significant events like the formation of the Earth. But that took 100 million years. It's not the kind of thing you could sit and watch and be patient with.
I don't know. I reckon if we could go back in time,
you could
go to the very beginning and hit fast forward.
Fast forward, yeah, that's right. Yeah, that's probably true. But my choice would be actually something similar to yours, because what you want is something that's dramatic and happens in the blink of an eye. And as long as I could be in a safe capsule somewhere, I would love to see the impact that wiped out the dinosaurs.
Yes.
To take myself to the region of Chicxulub in Mexico, sit on the sidelines, just wait a few minutes while all these dinosaurs chew around and see what happened. Because it would have been quite spectacular.
It would have been extraordinary. Yeah, I didn't think of that one. I don't know why, but yeah, I'm glad you brought it up. That's a ripper.
Well, we both went for impact. Neither of us said witness a supernova explosion or the formation of a black hole or the collision of two black holes. We didn't say all that. We just want to see the impact.
No, I think he was probably, well, I guess he means anything in the history of the universe, but I was sort of keeping it local.
Me
I
too.
did think of a supernova, because they have had eyewitness accounts written in history about some of those.
Yeah, that's right.
But the Chinese witnessed a big one,
but not from close up.
No, that would not be advised. No, not at all. Thanks, Peter. Lovely question. I think that'd be a great discussion question on the Space Nuts podcast group as well, if you wanted to get on there and pose the question and see what people came up with. I'm sure everyone has their own ideas as to what they'd love to see in the history of the universe if they could go back in time and witness it. And if you do have questions for us, of course, you know what to do. You go to our website and you click on the thing on the right that tells you, to record a question, or you go to the AMA tab, because that's where it all happens. And you can also go old school and send us an email with a text question. So that's on the AMA tab, or you can go on the button on the right that says send us your voice message. That's how it works. If you've got a device with a microphone, if it's a tablet or a phone or a desktop or a laptop with a microphone in it, you can send us an audio question. Don't forget to tell us who you are and where you're from. People are getting much better at that. That brings us to the very end of another episode. Fred, thank you so much.
It's a pleasure, Andrew. Good to see you as always, and we'll speak again soon.
We will indeed. That is Professor Fred Watson, astronomer at large, and he'll be joining us again next week on the next episode, coincidentally. And from me, Andrew Dunkley, thanks so much for your company. We'll catch you again next time. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.